Now let's look at horizontal translations. And there's a special word that we use with trig graphs when we're moving them left and right, and the word is phase. Now we already know how to make a horizontal translation. To slide a graph left or right, we normally just replace x with x plus or minus something. And we've learnt that adding something, let's say b, shifts a curve b units to the left, whereas subtracting something shifts it to the right. Well, let's think about what we know about the trig curves. Sine goes on and on like this. Cos starts higher, but it goes on and on doing the exact same shape. We've got the tan curve, which goes on and on like this. So if we take a section of any of our trig curves and we slide it along, when it goes along the length of the period of the curve, which is the amount of time it takes for it to repeat, when we slid it that far, it's going to sit exactly on top of itself again. So we will have achieved virtually nothing. We'll have the same curve. So because of this, we make it simple and we say, let's just describe all sliding left and right in one direction only. Let's just always go left, because going left a little way is going to be the same as going right a little way. We're going to end up sitting on top of the next part of the curve, whichever way we go. So the convention is to go to the left. Now, why the left? Well, I guess going to the left means that in your formulas, you end up with a nice tidy x plus something all the time, instead of x minus something. And that's just a nice sort of convention. You have to pick one way or the other, and I guess that makes sense. So, we've written this down here with trig curves. We call this the phase, or the phase shift, and it's always to the left. So a function written like this, these functions all have phase or phase shift of b, and that tells us that they've moved the basic curve b units to the left. Now, many phases are the same. So phase is closely related to period. This makes sense if we think about the sine curve, starting here, doing one full rotation when it gets to 2 pi. If we were to move to the left a whole 2 pi, it would be the same as if we moved to the left 4 pi, or 6 pi, or 8 pi, or 10 pi. And you could see also that if we were moving to the left minus 2 pi, that would actually be the same as moving to the right. So, here's what we need to do. When you're thinking about a shift, for example, if we're shifting y equals sine x to the left, pi on 2, that would be exactly the same as shifting it to the left pi on 2 plus another 2 pi, wouldn't it? Because it would sit on itself again. Plus another 2 pi, plus another 2 pi. So, pi on 2 plus 2 pi is 5 pi on 2. And that would be the same as shifting it to the left 9 pi on 2. And this would go on and on and on to infinity. It would also be the same to shift it to the left a negative amount. Now notice that if I take pi on 2 and I subtract 2 pi from it, what I get is minus 3 pi on 2. And if I subtract another 2 pi, I'll get minus 7 pi on 2. This makes heaps of sense because it takes us back to our original idea that if we were doing x minus something, then it would shift it to the right, wouldn't it? So if I'm taking a curve that's got a period of 2 pi, and I'm thinking about shifting it to the left a quarter of its period, it's the same as shifting it to the right 3/4 of its period, isn't it? Now, we always go to the left, true. I'm not trying to confuse you here by talking about going to the right. It's just that if you're going to the left a negative amount, that's pretty well the same as going to the right. And it is kind of still written in this format. It's just that if b is negative, then you're adding a negative number. So effectively you are going to the right. We just write it this way. And we say that whatever b is, that's the phase. So the phase could technically be negative. And moving to the left a negative amount would actually be moving to the right. Now, something that we need to remember is horizontal dilations and translations don't commute. We learnt this already last lesson. If they don't commute, that means that you need to be careful which order you do them in, or it's going to make a difference. So our rule is, if we're not sure, we always perform the dilations first, and then the translations. So the dilations that wouldn't commute would be horizontal ones. Vertical ones would be fine, you could do them in any order, but a horizontal dilation and a horizontal translation you have to be really careful. Dilation's first, then shifting left or right.